Hi everybody, welcome back to Beginning Algebra. Today we are in section 5.1 and we're going to start talking about exponents. So in this section we will learn the product rule for exponents and three variations of power rule for exponents. So our objectives in this section are that we're going to review how to use exponents, we're going to talk about the product rule for exponents, and then we have three different power rules we're going to look at. And then we'll do some problems that ask us to use a combination of the rules. And this last objective is where we'll try to tie everything else together. So let's go ahead and take a look. So first, let's review a little bit about how to use exponents. Remember from our previous lessons that an exponent tells us how many times a factor is repeated in a product. So for example, 3 times 3 times 3 times 3 times 3 is 3 to the 5th power, which would give you 243 if you multiplied all of these 3's together. Now, if no exponent is written, then the exponent is understood to be a 1. So, for example, if you just have a 3, that's understood to be 3 to the 1st power. And an exponent can affect only the number or variable that it is attached to, so to speak. In other words, it can only affect the base. It can't affect other quantities that are multiplied by the base. So for example, 7 times x squared is equal to 7 times x times x. It's not 7x times 7x because you see the exponent of 2 is attached to the x, so it only can affect the x and not the 7. If you did want an exponent to represent 7x times 7x, you'd have to keep the whole thing in parentheses and put the exponent on the parentheses. So you see in this case the 2 is the exponent and the base is everything in parentheses. Now in the same way, negative 3 squared with no parentheses is actually just negative 1 times 3 squared. So the square is only affecting the 3, not the negative. I know it looks like the exponent should be affecting the negative, but it is not. Because remember, the exponent can only affect the number it's next to, not anything multiplied by the base. So the 3 is the base, and the negative 1 is just a number multiplied times this exponential expression. So negative 3 squared is negative 1 times 3 squared, so that's negative 1 times 3, so that's negative 9. It's not negative 3 times negative 3, and this is what everybody thinks it ought to be, but it's not. In order to make a base negative, we have to have that base in parentheses. Just like on the last slide, in order to raise the whole 7x to a new power, we had to have the 7x in parentheses. So for example, negative 3 in parentheses to the second power is negative 3 times itself, and that would be positive 9. So let's look at example 1 together, and in this example we want to identify the base and the exponent of each expression, and then we'll evaluate. So let's take the expression 5 to the 4th power. Of course here the base is 5 and the exponent is 4, and the value would be 5 times 5 times 5 times 5. Now I don't know if you know this one off the top of your head, but of course 5 times 5 is 25, and then we'd have a 25 here. So 25 times 25 would make 625. If you didn't know that off the top of your head, you'd just have to go on a piece of scratch paper and just multiply it out. Not a big deal. Then for this second one, we have negative 5 to the 4th power. So remember, as odd as it seems to you at first, the base here is still 5, and the exponent is 4. And the negative is just like a negative 1 that's being multiplied by 5 to the 4th. So the value here is negative 1 times 5 times 5 times 5 times 5. You see the 5 is the only thing getting repeated here. So this would be negative 625. Now here we have negative 5 in parentheses raised to the 4th power. So the base here is everything in parentheses because you see the exponent is attached to the parentheses. So here the base really is negative 5 and the exponent is still 4. So what we have here is negative 5 times negative 5 times negative 5 times negative 5. So 4 negative signs are going to make a positive answer, because remember, every 2 negative signs make a positive. That means an even number of negative signs multiplied together will make a positive. And so we're going to get positive 625 here. Okay, now we're ready to start talking about the product rule for exponents. Now, instead of just telling you what the product rule is, let's see if we can just discover it by ourselves. So the instructions here say write each of the following without exponents and then restate using only one exponent. Okay, so we have 2 to the 4th times 2 to the 3rd. So of course you know 2 to the 4th is going to be 2 times 2 times 2 times 2. And that's going to be times 2 to the 3rd, which is 2 times 2 times 2. Now, gather all of these 2's back up and express the answer with just one exponent. So here, since this is all multiplication, we have 1, 2, 3, 4, 5, 6, 7 2's all being multiplied together. So this is equivalent to 2 to the 7th power. And let's try it again here. We have 6 to the 2nd power times 6 to the 3rd power. So without exponents, 6 to the 2nd is 6 times 6, and 6 to the 3rd is 6 times 6 times 6. And now let's write this with just one exponent. So we've got 1, 2, 3, 4, 5 6's here. So that's going to be 6 to the 5th power. Now I'm not worried about working out these numbers. We could do that. We could just sit down and multiply 2 times 2 times 2. We could put the 2 down 7 times. But the point here is that if you have a base with an exponent multiplied by the same base with an exponent, the way to get the base with just one exponent is to add the exponents. Can you see that here? That we have 4 2's from this factor and 3 more 2's from this second factor. So that's a total of 7 2's. And here we have 2 6's from this factor, 3 more 6's from this factor. So we ended up with a total of 5 6's. So now we can see that when we're multiplying expressions with the same base, we should add the exponents and keep the same base. So that is basically the product rule. So here it is officially written down, the product rule for exponents. For any positive integers m and n, a to the m power times a to the n power is equal to a, same base, to the power m plus n. So we add the exponents. Keep the same base and add the exponents. Okay, so here we have 6 to the 2nd power times 6 to the 5th power. If we wrote it without exponents, that would be 6 times 6 times 5 more 6's, and that's a total of 7 6's. So that would be 6 to the 7th power. Now that we understand the product rule, we will no longer write the expression out this way, which is the long way. We'll just use the product rule to add the two exponents together and be done with it. So here's example 2. This says use the product rule for exponents to simplify each expression if possible. So here we have 6 to the 3rd power times 6 to the 5th power. So we're not really worried about multiplying out 6 to the 3rd power and getting the actual number for that. What we want to do is write this expression with just one exponent. So 3 6's here times 5 more 6's here gives us a total of 8 6's all multiplied together. So that is 6 to the 8th power. So again, notice that the base stays the same and we just add the exponents. Here on part B, we have negative 4 to the 7th power times negative 4 to the 2nd power. And notice that both of these negative 4's are in parentheses. So both of these expressions have negative 4 as the base. So 7 negative 4's here times 2 more negative 4's here. So the base is negative 4, and we have 9 of those. 7 here and 2 here. Okay, here on part C we have x to the 2nd times x, and there's no exponent visible. So you have to remember that if there's no exponent visible, the exponent is understood to be a 1. So what we really have here is x to the second times x to the first. Now the bases are the same, and so we will keep the base and just add the exponents. 2 plus 1 is 3. And still in example 2, here we have 3 more expressions to work on. In part D, we have m to the 4th times m to the 3rd times m to the 5th. Well, as long as the bases are all the same, then multiplying these together just means adding the exponents. So 4 plus 3 is 7, and 7 plus 5 is going to be 12. Now here on part E, we have 2 to the 3rd times 3 to the 2nd. Now notice that the bases are different here. This first factor has a base of 2, and the second factor has a base of 3. And because the bases are different, we cannot use the product rule on this expression. So if we want to simplify this one, we'll just have to work out the exponents and multiply the two numbers together. So that's what we'll do here. 2 to the 3rd is 2 times 2 times 2, and if you multiply those 2's together, you'll get 8. And then that's multiplied by 3 to the 2nd. Of course, 3 to the 2nd is 3 times 3, which is 9. And we know that 8 times 9 is 72. So the only way to work this one is to get rid of the exponents and just multiply the numbers together. Now here on part F, we have 2 to the 3rd plus 2 to the 4th. In this case, the bases are both 2, but we still can't use the product rule because remember, product means multiplication, and this is not a product, this is a sum because of the plus sign. So this is another case where we cannot use the product rule. So in this case, we'll just have to work out the exponents and add the two numbers together. 2 to the 3rd is 2 times 2 times 2. We said before that that is 8. And 2 to the 4th is 2 times 2 times 2 times 2. That's basically 8 times 2, so that's going to be 16. So we have now 8 plus 16, which is 24. So I want to make sure you understand why on E and F we could not use the product rule. We couldn't use the product rule on part E because the bases were not the same. And we couldn't use the product rule on part F because it's not a product, it's a sum. So knowing the rule is a good thing, but also knowing when you can't use the rule is absolutely very important. So now let's use the product rule to multiply 2x to the 3rd times 3x to the 7th. So first I'll just write it in a multiplication form. And you know, we could use the commutative property and the associative property to rearrange these things. We could group the 2 and the 3 together, and we could group all the x's together. But I don't think we actually have to write that down for you to see that that's possible. So here, all we have to do is combine the 2 times the 3, that would give us a 6, and then combine the x to the 3rd times the x to the 7th. Now just imagine, how many x's would you have to write if you had to write x to the 3rd without the exponent and you had to write x to the 7th without the exponent? Wouldn't you end up with a total of 10 x's? So x to the 3rd times x to the 7th is going to be x to the 10th. And that is all we can do to that multiplication. Now I want you to think for just a minute about the difference between adding and multiplying exponential expressions, because sometimes people get mixed up and they'll think they're adding, but what they're actually trying to do is use their multiplying steps. So when we're adding, we are combining like terms, and when we do that, we add the coefficients together, but the exponents stay the same. So 8x to the 3rd plus 5x to the 3rd, it's like we don't know what x to the 3rd is, but here we have 8 of them plus 5 more of them. That gives us a total of 13 x to the 3rd. Here in the second part, we have 8x to the 3rd times 5x to the 3rd. Now we know that when we multiply variables together, we add the exponents. So 8 times 5 would be 40, and x to the 3rd times x to the 3rd would be x to the 6th. Spend a little time thinking about that and make sure you have the difference between these two very clear in your head. Now we're ready to move on to one of the power rules. So the first one we're going to look at is this form right here, where we have a base raised to a power, and that whole thing is being raised to another power. Okay, so let's take this one as an example. We have 5 squared raised to the 4th power. So if you think about what this 4th power means, it would mean that we have to put 5 to the 2nd power down 4 times, all multiplied together. And now you can see that we can use the product rule. So we would add these exponents. 2 plus 2 plus 2 plus 2 would be 8. So this total comes up 5 to the 8th power. Now look back at the problem. 5 squared raised to the 4th power became 5 to the 8th. So can you think of a way that we could skip this middle step? Well, it looks like we should be able to multiply the inside exponent times the outside exponent. And that is exactly what happens. So this is power rule A for exponents. For any positive integers m and n, a to the m power raised to the n power is going to be a to the m times n. So this is different from the product rule now, because the problem here is not really a product, it is a power of a power. So that's why they call this the power rule. So when you raise a power to a power, you multiply the exponents together. So for example, 3 to the 4th raised to the 2nd power would be 3 to the 4th times 3 to the 4th. When you write it in this form, you can see that we need to add the exponents, so that would be 3 to the 8th. So what we want to do in the next example is not have to write out this middle step. We just want to take advantage of the power rule to get the final exponent. And so that's what we're going to do here in example 4. Use power rule A for exponents to simplify each expression. So here we have 2 to the 5th raised to the 3rd power. So remember, when we have a power raised to another power, we keep the base the same and we multiply the inside exponent times the outside exponent. So 5 times 3 is 15. So 2 to the 5th raised to the 3rd is 2 to the 15th. Similarly here, we have 5 to the 7th raised to the 2nd power. So the base stays the same, and we multiply the exponents. So this would be 5 to the 14th power. And then here we have x to the 2nd raised to the 5th power. So the base will stay x, and the new exponent will be 2 times 5, which is 10. Now let's look at the second form of the power rule. So just to get us started, let's think about what this expression means. 4x in parentheses to the 3rd power. If we had to write this without using exponents, then what we would have to do is put the 4x down 3 times. So we would put 4x times 4x times 4x. And now we want to use the commutative property to rearrange the 4's and the x's. That would let us write 4 times 4 times 4 times x times x times x. So actually we've used both the commutative property and the associative property. So now you can see that we have 3 4's here, so this would be 4 to the 3rd, and we have 3 x's all multiplied together, so that would be x to the 3rd. So now look where we came from and look where we ended up. 4x to the 3rd became 4 to the 3rd times x to the 3rd. So this suggests to us power rule B. Let me go ahead and give you power rule B. Here it is. It says if you have a product inside parentheses and the whole product is being raised to an exponent. So for example, a times b raised to the m power. Then what you can do to eliminate the parentheses is apply the outside exponent to every factor inside the parentheses. So a times b raised to the m power becomes a to the m power times b to the m power. In words, you could say that you raise a product to a power by raising each factor to that power. So let's do that here. 2p to the 5th power would be 2 to the 5th power times p to the 5th power. Now let's look at example 5, which will give us a little practice using power rule B. So we're going to take this expression 3xy all raised to the 2nd power, And let's see if we can use the power rule B to eliminate the parentheses. So we do have a product on the inside of the parentheses, and that means we can apply this outside exponent to everything inside the parentheses. So that's going to make 3 to the second power times x to the second power times y to the second power. Now, 3 to the second is an expression we can evaluate and eliminate that one exponent. So 3 squared is 3 times 3, so that's going to be 9, and that's times x squared times y squared. So this is as far as we can go with this expression. Now on part B, we have 3 outside the parentheses times xy to the second power. So this time, notice that the base of the exponent is just the xy, and the 3 is sitting in front. So we'll have 3 times, we'll apply this outside exponent to each factor inside. That will give us x squared times y squared, and that is fully simplified. Now for part C, we have 2m squared p to the third, all raised to the fourth power. So this is a product inside these parentheses, and that means we can apply this exponent to each factor inside the parentheses. That's going to make 2 to the fourth times m to the second raised to the fourth times p to the third raised to the fourth. Now we can do a little more to this expression. We do want to remove the parentheses, and we do want to evaluate this constant raised to a power. So 2 to the fourth, of course, is 2 times 2 times 2 times 2. If you work that out, that's going to be 16. Now here on m squared raised to the fourth, we'll need power rule A. So remember, anytime we have a power raised to a power, we multiply the exponents together. So that's going to make m to the 8th. And the same thing here with p to the third raised to the fourth, that's going to make p to the 12th. And now let's look at part D. And you might be tempted to just apply the power rule by saying 3 times 6 is 18. But you need to be a little careful here, because this negative is not part of the base for 5 to the 6th. The negative is in front. So what I want us to do is write this as negative 1 times 5 to the 6th. When you do that, you can see that we should apply this 3 exponent to both factors inside the parentheses. So that's going to make negative 1 to the third power times 5 to the 6th to the third power. So negative 1 to the third is just negative 1. And 5 to the 6th, this is a place where we can use power rule A, so that's going to be times 5 to the 18th. And then we can do away with the 1, and we can just write it in the form negative 5 to the 18th. Now keep in mind that this is not the same as negative 5 in parentheses to the 18th, because 18 negatives multiplied together would give a positive answer. But here we don't have 18 negatives all multiplied together. Here we have just a negative that's multiplied by 5 to the 18th. So this quantity is actually negative. Now another thing you need to keep in mind about power rule B is that you must have a product inside the parentheses that you're working with. So here, for example, where we have 4x in parentheses all squared, we can write that as 4 squared times x squared. But here where we have 4 plus x in parentheses all squared, we cannot just apply the exponent to each term in the sum. This has to be done a little differently, and I'll show you in a later section how to work out something like this. But just for right now, know that you cannot apply an exponent to a sum inside a pair of parentheses. Now, when we had power rule B, we had a product inside the parentheses. We can also restate this rule for quotients, and we will call this power rule C. So for any positive integer m, the quotient a over b, all raised to the m power, can be written as a to the m over b to the m, as long as b is not 0, because remember, we can never let a denominator equal 0. But look at what we're doing here. All we're saying is that if the whole fraction is raised to a power, you can apply that power to the top and to the bottom. So you can raise a quotient to a power by raising both numerator and denominator to that power. So let's see an example of power rule C. Here we have 5/3 all raised to the second power. And so according to power rule C, we should be able to write this as 5 to the second power over 3 to the second power. And that just lets us get rid of the parentheses. And then if you needed to, you could go ahead and evaluate each of these. But we're just going to leave this here because I just want to demonstrate to you how we used the power rule to get rid of the parentheses. Now let's practice using power rule C. So here we've got 2/3 all raised to the 5th power. So power rule C says that we can apply that exponent to the top and the bottom separately. So that's going to give us 2 to the 5th over 3 to the 5th. Now we're going to go ahead and work each of these out. So 2 to the 5th would be 2 times 2 times 2 times 2 times 2. And if you work that out, you'll get 32 for the top number. 3 to the 5th is going to be 3 times 3 times 3 times 3 times 3. And it might take a minute to work that out, but here's what I do. I say the first two 3's, 3 times 3 makes 9, and then 3 times 3 here makes 9, and then we have an extra 3, so to speak. So now 9 times 9 is 81, and you can just work out 81 times 3 and get 243. This is how I would approach it. So 3 to the 5th is 243, and then here's our final answer. On part B, we have 1/5 all raised to the 4th power. So power rule C says we can apply that 4th power to the 1 and the 5 separately. So we get 1 to the 4th over 5 to the 4th. Of course, 1 to the 4th is just 1. 5 to the 4th is 625 because it's 5 times 5 times 5 times 5. On part C, we have m over n all raised to the 4th. So the power rule C says that we can apply that 4 to both the m and the n. So that would be m to the 4th over n to the 4th. And because these are variables, that's all we can do here. So here is a summary of all the exponent rules we've learned so far. We have 4 rules. The product rule is named because the problem is a multiplication, which is a product. So a to the m times a to the n. We would keep the base the same and add the exponents like you see here. For power rule A, we said that a power raised to a power means we can eliminate parentheses by multiplying the exponents together. If we have a product inside a pair of parentheses, we can apply the outside exponent to every factor inside the parentheses. And if we have a quotient inside parentheses, we can apply the exponent to both the top and the bottom as long as the denominator is not 0. So that's just where we've been in this section. And now we're about to do some examples that require us to use combinations of the rules. So the instructions here are just going to say simplify. So you need to know what they expect us to do when they say simplify. At this point, based on the rules that we know, simplifying exponential expressions means that we work out any parentheses, so the answer will not have any parentheses in it. Each base will occur only one time, and any constants with exponents should be evaluated. Except I will say that sometimes if the constant is fairly large and the exponent is fairly large, so that evaluating that exponent would be a lot of work, we can get let off the hook for that, and you'll see that in an example that's coming up. But most of the problems we'll have small bases and small exponents that you can do either mentally or without having to do much work on paper. So here is example 7, and you're going to see that we'll be able to apply at least 2 rules in every problem. And just notice that the instructions say simplify each expression. So again, remember, simplifying means work it out so that the parentheses are not necessary and so that each base occurs only once. And if you have a constant raised to a power that you can work out relatively easily, you should go ahead and do that. Okay, so here we have 2/3 to the second power times 2 to the third power. Now the first thing people wonder when they see something like this is, how do I know whether 2 to the third belongs to the top or to the bottom? And what you have to remember is that 2 to the third is going to make an integer. And all integers have a denominator of 1. So even though the 1 was not written, you can put the 1 there if it helps you. And now you can see that this 2 to the third is going to end up getting combined with this 2 to the second. So let's go ahead and apply our power rule C that will remove these parentheses. So 2/3 to the second is going to be 2 to the second over 3 to the second, and then that's times 2 to the third over 1. Now we know that when we multiply fractions, we multiply top times top and bottom times bottom. So let's go ahead and use the product rule here on the top. 2 to the second times 2 to the third would make 2 to the fifth, because this is a product, so we would add these exponents together. And then in the denominator, 3 squared times 1 is still just 3 squared. Now both of these bases are fairly small, so it's not going to be difficult for us to go ahead and work this out. 2 to the fifth would be 2 times 2 times 2 times 2 times 2. You can tell up here that basically 2 to the fifth is 2 squared, which is 4, times 2 to the third, which is 8. And you know 4 times 8 is 32. So 2 to the fifth is going to be 32. And in the denominator, 3 squared is 3 times 3, so that's 9. And so here's our final answer for part A, just 32 over 9. And there's no need to change it into a mixed number, of course. Okay, so for part B, we have 5x to the third times 5x to the fourth. Notice that both of these bases are the same, and that means we can apply the product rule. So that would give us 5x in parentheses to the seventh power, because 3 plus 4 is 7. And now we have a way to apply power rule B, which says that if you have a product inside the parentheses, you can apply that exponent to everything inside the parentheses. And so that would give us 5 to the seventh times x to the seventh. Now, we really probably should work out 5 to the seventh according to the rules I gave you, but 5 to the seventh would be a very large number. 5 times 5 is 25, times another 5 makes 125, times another 5 makes 625, and you'd have to multiply by 3 more 5s to get to the end. So they're going to allow us just to leave the answer in this exponential form. But when you're in MyLabs Plus, you should watch for instructions that will either tell you to leave your answer in exponential form or enter your answer as an integer, which means that you're going to have to work it out. And here's part C. We have 2x squared y to the third all raised to the fourth power times 3xy squared all raised to the third power. So the first thing I want to do is eliminate these parentheses. So I'm going to apply this fourth power to everything inside the first parentheses and apply this third power to everything inside this parentheses. And in doing that, we are using power rule B. So let's write that out. That's going to be 2 to the fourth times x squared to the fourth times y to the third to the fourth times 3 to the third times x to the third times y squared to the third. Okay, now we have a couple of different things we can do. We should go ahead and work out these two constant factors, because 2 to the fourth and 3 to the third will be easy to evaluate. And then we should apply power rule A to eliminate each of these pairs of parentheses. So 2 to the fourth is going to be 2 times 2 times 2 times 2. If you work that out, that is 16. Then x squared to the fourth, this is a power to power situation, so we multiply the exponents. This is going to be 2 to the 8th. Y to the third to the fourth is another power rule A situation, so that's going to be y to the 12th. Now 3 to the third is 3 times 3 times 3. So 3 times 3 is 9, times the next 3 makes 27. And then we have x to the third, and then y squared to the third is going to be y to the 6th. Okay, the next thing we should do is get all of these combined so that each base appears only once. And these constants can just be multiplied together. So I don't know 16 times 27 off the top of my head. I would have to write that down and work it out. So that's what I'm going to do down here. 27 times 16 turns out to be 432. So I'll have that as my coefficient. And then we have x to the 8th times x to the 3rd. That gives us a total of x to the 11th, because this is a place where we would use the product rule. Notice that we don't have power to power like we did up here. Notice this is x to the 8th times x to the 3rd, so that's why we're adding. And then y to the 12th times y to the 6th would be y to the 18th. and then that one is fully simplified. Now we're ready to look at the last three. Actually, if you would like to pause the video and try this one on your own, it's very similar to part C, but now I'm going to go through it with you. So here we have negative x to the third times y all to the second times negative x to the fifth y to the fourth all to the third. Now the first thing we need to remember is that because this negative is not in parentheses with the x, this 3 does not apply to this negative. So what we've got here is like negative 1 times x to the third times y all squared. And then same thing here, we have negative 1 times x to the fifth times y to the fourth all to the third. So now what I'm going to do is apply these two outside exponents to everything inside their parentheses. So that's going to make negative 1 squared times x to the third squared times y squared. And then this one's to the third power, so that's going to be negative 1 to the third times x to the fifth to the third times y to the fourth to the third. Okay, now, negative 1 squared is negative 1 times negative 1, that's positive 1. X to the third squared, that's a power rule, so that's going to be x to the sixth. And then we have times y squared. And then we have negative 1 to the third. So that's going to be negative 1 times negative 1 times negative 1. That's going to end up being negative 1. And then times x to the fifth to the third. So that's x to the 15th. And y to the fourth to the third is y to the 12th. And now we need to combine all of these so that each base occurs only once. We'll start by multiplying the constants together. So we have 1 times negative 1. Of course, that's negative 1. And then x to the 6th times x to the 15th is x to the 21st. And then y squared times y to the 12th is going to be y to the 14th. And then, of course, this 1 is not strictly necessary. We can just have the negative in front of the x. So we could write this as just negative x to the 21st, y to the 14th. Now let's look at part E. Here we have a quotient raised to the third power. So remember the power rule C told us that we can apply this 3 to both the top and the bottom. So that's going to give us 4x squared to the third over 5 to the third. And then we can use power rule B on the top here. So power rule B said we could apply this 3 to all the factors of this product. So that would give us 4 to the third times x squared to the third over 5 to the third. Now we'll evaluate each of these and we'll use a power rule here. 4 to the third is 4 times 4 times 4. You might have to jot that down and work it out, but I'm just going to go ahead and tell you that's going to be 64. X squared to the third, you would use the power rule to simplify, and that would be x to the sixth. And then in the denominator, 5 to the third would be 5 times 5 times 5, that's 125. Here on part F, we have 5x squared b to the fifth all over c to the sixth, all of that raised to the third. This is very similar to what we had in part E, so I would encourage you to pause the video and try this one by yourself. And now I'm going to go through it with you. So power rule C says that we can apply this 3 to both top and bottom. That's going to give us 5x squared b to the fifth all to the third over c to the sixth to the third. And then power rule B says we can apply this 3 to everything inside that parentheses. So that would give us 5 to the third, x squared to the third, b to the fifth to the third. And that's still over c to the sixth to the third. And then we just need to go through and simplify each factor. 5 to the third is 125. X squared to the third is x to the sixth. B to the fifth to the third is b to the 15th. And in the denominator, c to the sixth to the third is c to the 18th. And that's as far as we can go with that one. So, you know, exponent rules just take practice. We only have half of them. There's another half coming in a later section. But these problems are tricky for a lot of students, and I think the more different kinds of problems you look at and practice with, the better you'll get with this. So do spend some time practicing on these types of problems.